right, so we are going to continue with numerical values that are coming from describing quantitative variables today. We're going to look at box plots, and then we are also going to look at analyzing measures of spread. So in order to kind of get us started, when we make a box plot, we need what's called the 5-number summary. And part of this we had seen yesterday. We saw the Q1, Q3 and the median. And so those are all part of the 5-number summary, and we just add to it the minimum and the maximum value. When you report the 5-number summary, usually those values are listed from smallest to largest. So they would be in the order that you see here. Your graphing calculator will find the 5-number summary for you, as will many other statistical packages. So things like those online resources like Statlet and StatKey will also find those 5-number summaries, and we'll take a look at that in just a few minutes. So as I said, you can use the 5-number summary to make a box plot. So when you go to make a box plot, you're going to start by drawing a number line or a labeled x-axis. And so this is important because you want to make sure that your scaling is correct. So a lot of students tend to try and draw their box plot and then put the axis in later. Make sure you're doing the axis first so that the spacing is in fact what it should be. And then once you have your axis, you're going to go ahead and draw a box that spans from Q1 to Q3. And then you're going to note your median within that box. So your median is going to be a vertical line inside. And then you're going to extend your whiskers. Your whiskers are going to go to your highest and lowest values that are not outliers. And we'll see what that means in just a minute. But if you have outliers, you're going to mark those separately. So here's that travel time data that we had seen yesterday, and we're going to go ahead and just put that in order again. And so here those highlighted values are highlighted because that's where we're going to go to find Q1, the median, and Q3 as we did yesterday. So to make the box plot, as I said, most important thing is to make that labeled x-axis first. Your x-axis does not have to start at 0 like we saw when we made bar graphs. We're just starting at 0 here because the smallest travel time over here is the 5. So it would make sense to start at 0. And then again, just even spacing. You can see that the distance between 0 and 10 is the same as between 10 and 20 all the way through. So we're going to go ahead and put that central box in. That box is going to go from Q1 to Q3. So Q1 was 15 and Q3 was 42.5. And then the median gets marked within that box. So that's the vertical line that we're seeing here for the median. Then you're going to put your whiskers in. So the lower whisker is going to extend all the way down to 5 because we had no low outliers. However, you're having a high outlier at 85. We're only going to extend that top whisker to the next highest entry. So that right-hand whisker is going to go up to 65. And then we mark the outlier separately. So you can see that here just marked with a separate dot. And so the reason that we really want to make sure that we evenly scale that x-axis is because we can see that in this case, our distribution is probably skewed to the right. This right-hand side of the box plot stretches out for further than the left-hand side over here. So I'm just going to make a note here that we have a right skew. Shape is somewhat difficult to assess from a box plot. We do want to be careful and not say that something is symmetric from a box plot, even if all kind of 4 chunks are about the same, just because there could be other things going on when we looked at something like a histogram. Like you might see something that's bimodal, or you might see some peaks or gaps that aren't apparent in the box plot. So we do want to be careful. We can say that we have skew, but other than that, there's not much we can say about the shape from a box plot. The other thing that I do want to mention when we're looking at box plots is that we talked about yesterday, your quartiles are marking the quarters of the distribution. So each chunk of your box plot is representing 25% of the data set. So this line here, this lower whisker is 25%. Here's another 25%, another 25, and another 25. So even though those sections are much longer on the right-hand side, it's still representing 25% of the data. It's just that that top half of the data set is further spread out than the bottom half. So another measure of spread that we have, aside from the IQR, which we talked about yesterday, is called the standard deviation. And I'm going to walk you through how to find this, and then we'll talk about using technology to calculate standard deviation, because you're going to see in just a minute here that it's a pretty tedious process. So if you have a data set that's fairly large, you're not going to want to calculate standard deviation by hand. So here we have a dot plot that shows us how many pets are owned by a group of 9 children. And so when we go to calculate the standard deviation, the first thing we have to do is calculate the mean, because what the standard deviation tells us is typically, or on average, how far values tend to fall from the mean. So we need to find that value, and then we're going to find the deviation, because again, we want to find how far each of those values deviates from the mean. And so deviation is just the difference from the mean. We are always going to subtract in the order of observation minus the mean, so you could potentially have negative deviations, and we're going to take care of that in a couple minutes by just squaring those deviations. So here in this dot plot, the mean is 5, so we want to find each deviation. So we're going to find out how far this value is from the mean, this value from the mean, all the way through the whole data set. So this value here at 1 would have a deviation of -4, because we're going to take 1 minus 5. This value here at 7 would have a deviation of 2, because it would be 7 minus 5. This point here at 5 is going to have a deviation of 0, because it's located at the mean. So here's just another example like I had stated. So here, we're going to take a look at our data set. So this column of the chart here is just the individual X values that came straight from this dot plot over here. So then we're going to find those deviations. So again, that's the observation minus the mean. So that's the list that we're seeing here. And as I said, some of those deviations are negative. So because we have negative deviations, we want to square them to make them positive. So that's going to be the next column that you see. So it's just the -4 squared, the -2 squared, all the way through. And then we want to find the average squared deviation. So we're going to go ahead and add those all up, and then we're going to divide by how many. But something that happens when we find standard deviation and what we call variance here is that we divide by n minus 1. So we have nine children here, so we're actually going to divide by 8. So this 52 is the sum of this column here. So I'm going to go ahead and write that in. And then we're dividing by 8. So we get 6.5. That's what we call the variance, which is a measure of spread. But we usually use the standard deviation in statistics. So we're going to take the square root of that variance, which really undoes this squaring process here, to get our standard deviation. So our standard deviation in this case is 2.55. So the big piece that we're going to see is we're going to want to calculate standard deviation using technology, because again, you can see that this is quite a bit of work for a very small data set. And then once we find standard deviation, we want to be able to interpret it. So this is telling us our mean was 5. So I'm going to go ahead and put that up here. So we're saying on average, these children have 5 pets, but we tend to differ from that average by this 2.55. So average is 5 pets. On average, students or children are differing from 5 by about 2.55 pets. Because again, we don't expect everybody to be the average. And 2.55, that's a pretty big standard deviation when we think about it in terms of pets, because you're talking about 2.5 pets. But we can see here that this is pretty spread out. We do have a lot of variation in this dot plot. Okay, so here is your formal definition for standard deviation and the symbol that goes along with it. So here, this S sub x is the symbol for sample standard deviation. And you are going to be expected to use appropriate statistical symbols. So you will need to use S sub x for your notation. And again, it gives us the average distance of the observations from the mean. And then when we talk about our variance, that's the square of the standard deviation. So our symbol for variance is just S sub x squared. So nothing fancy there. Here's your formula, and this is another one of those formulas that is in your formula packet. As I said before, we really don't want to have to calculate standard deviation by hand. And so because of this, you're probably not going to have to use this formula, but because it is in the formula packet, technically it is fair game for the AP exam. Although I've never seen an AP exam where they've had students calculate standard deviation by hand. It's in the formula packet with this summation notation. And so just to kind of explain to you what everything is here, this is our variance. So we'll see standard deviation in a second. It's the individual x value minus the mean. We square that. We add that all up to find the sum. And then we divide by n minus 1 or multiply by 1 over n minus 1. So that gives us the variance. And then the standard deviation is just the square root of that. So again, this formula being in the formula packet, if you needed to use it, like I said, individual x value minus the mean, square each of those, find the sum, and then divide by n minus 1. Like I said, I've not seen that required on the AP exam, but it is there, so technically it's fair game. I am not going to ask you on any tests and quizzes to use the formula. I will allow you to use the calculator or technology. So here is a little comic for you. Okay, so we have several measures of center and several measures of spread. We have mean and standard deviation and median and interquartile range, and those two are really paired together. So if you're going to report the mean, with the mean, you're going to use standard deviation as your measure of spread. If you're going to report the median, you're going to use the IQR as your measure of spread. And so in terms of choosing which to use, it really depends on the shape of your distribution. So the first thing you should do when you have a data set is graph it. Once you've graphed it, you can determine the shape, and then that shape will determine then what measure of center and spread you should use. So we use the median and IQR if the distribution is skewed or if it has outliers. And the reason for that, if you remember yesterday, we talked about how skewed distributions are going to pull the mean towards the skew. So the mean is what we call a non-resistant measure of center. It's impacted, or it does not resist the influence of skew and outliers. So because of that, it's not a very good representation of center if we have skew or outliers. So in that case, we're going to go ahead and report median and IQR. If your distribution is somewhat symmetric, so you're reasonably symmetric, then we can use the mean, and with the mean we would report standard deviation as our measure of spread. So now that you have multiple choices for how you're going to report center and how you're going to report spread, you want to make sure that you're specific in your description. So you don't want to just say the center is 22.5, you would say the median is 22.5, or the mean is 31. You want to make sure that you're identifying which measure of center you're using. And then the same thing for the measure of spread. The standard deviation is 2.55, or the IQR is 6, whatever the case might be. So as I was saying, you always want to plot the data first to figure out the shape of the distribution. And then once you've determined that shape, you're going to use the mean and standard deviation if it's approximately symmetric, or median and IQR if it's skewed or has outliers. So here's a summary of section 1.3 overall, so yesterday and today. We want to make sure with our numerical summaries that we report at least center and spread, but we should also be checking for outliers as well. Mean and median describe the center of a distribution. Again, we always want to make sure that we identify which measure of center we're reporting. And then if we're using the median, we can describe the spread with the IQR, which is really just showing us the middle 50% of observations. We also know how to check for outliers using that 1.5 times the IQR rule. And then our 5-number summary can help us make a box plot like we saw earlier today. And then we had variance and standard deviation. So we use standard deviation to report variability if we are reporting the mean for the center. And again, the variance is the square of the standard deviation. We use mean and standard deviation if the distribution is approximately symmetric, median and IQR if it's skewed or has outliers. So for your assignment, you have some bookwork, and actually I should take this Ages of Actresses worksheet off of here. We're not going to do that. And then we are going to have a 1.3 quiz on Friday. So I'll talk to you about or send you details on that, since Friday is an asynchronous day in terms of how you're going to complete your quiz. And then if you do want additional practice, Khan Academy topic for today would be box and whisker plots. So I want to go ahead and show you guys how to use technology to find standard deviation. Okay, so I had shown you guys the stat key yesterday, and I showed you that you can enter your own data. So again, if you hit edit data, you can type everything in a column just like you would in your calculator. And this is the same data set with the travel times for New Yorkers that we saw yesterday. So we yesterday talked about mean, we talked about median, Q1 and Q3. You can see here that you have the whole 5-number summary. So you have the minimum and maximum included as well. And then the computer also finds standard deviation for you. So here's the standard deviation of that data set. So this is telling us on average, it takes these individuals about 31 minutes to get to work, but we vary from that average by about 22 minutes. And so that is a fairly large standard deviation, but if you remember, this data set did have that outlier at 85, and it is pretty well spread out. We can see that from the dot plot. So that's why your standard deviation is large. If our dot plot was more compact or condensed, we would see then a smaller number for that standard deviation. I also want to show you here on StatKey, if I click on this box plot tab, it's going to show me that modified box plot. So again, here's our box plot, and then that outlier at 85 is denoted. And if you hover over, it gives you the value for that point. These, it doesn't show you, but again, you can pull the 5-number summary from the chart on the right. The other option that you have that I think is maybe a little bit easier to input the data is Statlet. And I know that I had said yesterday it wasn't working. I think it just had a lot of traffic on the site, but I was able to get it up and running today. So we have one quantitative variable from one group here, travel time of one group of New Yorkers. So I'm going to say one quantitative variable, single group. And then I clicked on that and opened up this tab over here. Then you just input your data. So I just gave it a title. I said travel times, and then I just put all of those numbers in separated by spaces. And then I can go ahead and hit the begin analysis, and it's going to give me the same information that I can get from StatKey. So just another option for you. Here's your mean, here's your standard deviation, here's your 5-number summary, and then here's our dot plot. Again, we can change the type of graph. So if I wanted to make a box plot, I can go down and select that. And again, it does show you the outlier here because it's a modified box plot as well. The last thing that I want to show you for today is how you can use your graphing calculator to make both a box plot and show you where that standard deviation is located. Okay, so here is my graphing calculator. I have entered the data already, so if I hit Stat Edit, you can see that I have the data from this set in my calculator. And to find the standard deviation and the remaining parts of the 5-number summary, those are just under the one variable stats like we saw yesterday. So if I hit Stat and then Calc and then one variable stats, I just tell my calculator where the data is stored. So again, we can do second and then the number 1 for L1. If your calculator doesn't have this here, if it just says one variable stats, then you just type in an L1 after it. Frequency list we leave blank, and then we can hit calculate. And so then we see the mean there like we saw yesterday. And then if you look, the 4th item down is that SX, which is our standard deviation. So that's that 21.9 minutes roughly. If I scroll down to where I saw my quartiles and median yesterday, you can see I have the complete 5-number summary. So I have the min and the max there as well. We can also make those box plots on the calculator. It's the same window that we use to make histograms. All of your statistical graphs are going to be in that stat plot menu. So if I hit second and then y equals, again, if any of these plots are on, I can go ahead and turn them off, either by going into the plot and selecting off, or I can turn all of the plots off with option 4, because if you're trying to make too many graphs at once, it could be problematic. So if I go ahead and hit enter on option 1, I'm going to turn plot 1 on, and then I want to pick the box plot. But if you notice, there are 2 box plot options. The first option has those little dots after it. The second one does not. The one with the little dots is the modified box plot. That's the one that's going to show us the outliers. So I want this one here, again, that's going to denote any outliers. My X list is where I have my data stored. So I want to put in list 1 here. My frequency I leave as 1. And then where it says mark is just how I want the outliers to appear. So that's just a matter of personal preference. I'm just going to leave it as it is. Then I can hit zoom. Again, if this pops up, if I hit second and then mode, that's going to quit me out. I can then hit zoom and then option 9 for zoom stat. Oops, and you can see I have an algebraic equation that's trying to graph here as well, which could potentially happen to some of you guys. So if I want to get rid of this line here, if I hit y equals, I can go ahead and hit clear and clear that out. So now if I hit zoom 9, I have just my box plot. And if you ever get any sort of a domain error, it could potentially be because you have something in your y equals equation. So you can go in and hit y equals, clear that out. That's kind of a good troubleshooting tip for you. So now if I hit my trace key, it's going to put a cursor up there and it will give me the 5-number summary. So it's going to tell me my minimum is 5, and then I can scroll through to find my median and quartiles. Again, that next highest value that's not an outlier was 65, and then that outlier is marked at 85.